Welcome back, developers and design pattern enthusiasts. Today, we're diving into one of the most flexible and powerful patterns in object-oriented programming, the strategy design pattern. Whether you're building a game, an e-commerce platform, or a machine learning pipeline, the strategy pattern helps you write cleaner, more maintainable code by separating behavior from context. Stick around, because by the end of this video, you'll not only understand how it works, you'll be able to implement it confidently in your own projects. Let's start with a real-world analogy. Imagine you're planning a trip. You can choose to travel by car, by train, or by airplane. The destination stays the same, but the mode of transportation varies. In this case, the trip is your context, and the transportation method is the strategy. You can swap out strategies, so you can drive, or fly, or ride the train without changing the trip itself. And that's exactly what the strategy pattern allows you to do in software. Change the behavior of an object dynamically without altering its core structure.
Now let's walk through a code example to see the pattern in action. We're building a simple payment system where users can choose between paying with a credit card or by PayPal. Now first, we'll define a payment strategy interface. This is our contract. All payment methods must implement the pay method. Next, we create two concrete strategies. The first one is the credit card payment. Now let's create a second one and call it the PayPal payment. Each one provides its own implementation of the pay method. Then comes our shopping cart class. This is the context. It holds a reference to the payment strategy and delegates the payment process to it. Notice how we can switch strategies at runtime using the setPayment strategy method. In the main method, we create a card and pass it the credit card payment strategy. The user checks out and pays 100. Then we switch to the PayPal payment and the user pays 200. The beauty here is that the shopping cart doesn't care how the payment is processed. It just calls pay. This makes the code flexible, extensible, and easy to maintain.
So why do we use the strategy pattern? Because it promotes open-closed principle. Your code is open for extension but closed for modification. It helps you avoid long if, else, or switch statements by encapsulating behavior into separate classes. And it makes your code more testable and readable and easier to maintain. Use the strategy pattern when you have multiple algorithms or behaviors that can be swapped at runtime. You want to isolate behavior from the object that uses it, or you need to follow the open-closed principle and avoid modifying existing code. A classic example would be sorting algorithms. You might want to switch between a quick sort, a merge sort, or a bubble sort, depending on your dataset. Now let's break down some of the pros and cons. The pros: it promotes clean code structure, it supports runtime flexibility, and it encourages reuse and testing. And the cons: it can lead to many small classes, slight overhead in managing strategies, and it might be overkill for simple logic. In short, the strategy pattern shines in complex systems where behavior needs to be interchangeable, but for simpler cases, it might be more structure than what you need. And there you have it, the strategy design pattern demystified. If you found this helpful, give the video a thumbs up and subscribe for more deep dives into software architecture. Got a favorite design pattern or a real-world use case you want to explore next? Then drop it in the comments below. Until next time, keep your code clean, your patterns sharp, and your strategies flexible.